Hello, my name's Owen, and I'm going to show you how to set up Otherplan to mill circuit boards on the Othermill. The first thing we'll do is set up our material. Click the Setup Material button and choose single or double-sided FR1. Now we'll set the dimensions of the board. The standard 5x4 inch setting works fine if you're using the boards we sell in our store, but if you have a pair of digital calipers, it's always a good idea to measure the exact dimensions of your material and input those dimensions here, because they can vary from board to board. Thickness is particularly important with circuit boards because you're only cutting a few thousandths of an inch deep. If you're just doing a single-sided board, click Align to Spoil Board in the Material Origin dialog, which will tell Otherplan that you'll be aligning the circuit board with the lower left corner of the spoil board. For double-sided boards, you'll need to use the alignment bracket. For more information about that, click the link below. Now I'll import my Eagle board file. This particular file is an Arduino clone that you can make on the Othermill. You can also import a set of Gerber files. When you select the file that has the top copper layer, Otherplan automatically selects any associated files that it finds in the same folder that have the same name. Using the placement panel, or double-clicking, you can move the design anywhere you want on your material. I'll move it a little away from the corner so we can be sure to have a nice clean edge when we cut the outline. Now you need to choose which end mills you're going to use to mill the board. The smaller the space between the traces and components on your board, the smaller the end mill you'll need to mill them out. You can combine multiple sizes of end mill to efficiently mill the fine details with a small tool and the larger areas with a larger tool. For the fine detail, I generally use a 1/64th or sometimes a 1/100th inch end mill, and for everything else I generally use a 1/32nd inch end mill. The motion plan is a visual indicator of where the tool will cut. You can toggle it on and off right here. A 1/32nd inch flat end mill comes automatically selected for circuit boards because it's the most commonly used tool. As you can see by looking at the motion plan for this board, the 1/32nd inch tool gets pretty much everywhere. However, there are a couple small areas that it can't reach, like between these vias and this trace here. You can see that there's still copper between them, so we need to load a smaller tool, so I'll load a 1/64th inch tool. Now with the 1/64th inch tool, you can see that there is no longer copper joining these vias in this trace, so we're good to go. For really tiny spacing, like if I were to load up this TQFP chip, you'll see that a 1/64th inch tool won't get between these pads because they're too close together, so you'll need to use a 1/100th inch end mill. Once I load that, you can see by the motion plan that it gets between the pads. Now to optimize for speed, we wouldn't also use a 1/64th inch end mill because there's nothing that a 1/32nd inch can't cut that isn't already being cut by 1/100th. So adding a 64th would only slow us down. After you choose your tools, decide if you want to cut traces, holes, board outline, or a combination. For a single-sided board, you'll usually want to select all three, but for a double-sided board, you'll need to wait to cut the outline until you've milled both sides, and you only need to drill the holes once, so you can choose which side you want to drill them on. Once you've done that, your job is ready to mill. Enjoy!